This video deals with Coulomb's law. Coulomb's law describes the force between any two charged particles. So anytime you see two charges separated by some distance in a formula, you want to use this guy, Coulomb's law. So it sets up pretty similar to Newton's law of universal gravitation. We have a force term is equal to some constant times the product of the two charges over the radius squared. Now, unlike gravity, Q can either be positive or negative. The force can either be attractive or repulsive, depending on the signs of Q. We'll talk about that more in a second. It's also much, much stronger than gravity. So most forces that we're used to dealing with are electrostatic in nature. So the fact that I'm not falling through my chair right now is because my butt molecules and my chair molecules, well, they have electrons on the outside, which are being electrostatically repelled. So you should kind of already get what's going on here. We have two positives, and these should repel each other. So it's going to have a repulsive force, and that's because the product, Q1 times Q2, is positive, so it's going to increase the distance between the two. If instead we have a positive and a negative, that's going to be an attractive force, because negative Q times positive Q gets me a negative force. And then the last one is also repulsive, because when you take a negative times a negative, you get a positive force. It's going to increase the distance between the two. Now, if I were to increase the charges on any one sphere, what I would find is that I would also increase the force. So if I double the number of charges, I double the force acting. If I were to go and double the charges on both spheres, then this would be 2 times 2 and have a force 4 times bigger. So it's going to be directly proportional to the product of the charges. Now, just like gravity, it depends on how close they are together to each other. So if I take this sphere and move it closer, I get a force 4 times greater. So I've halved the distance, and the force is 4 times greater, not twice as great, like it would be if it was inversely proportional. And here's why. It's an inverse square. So that means what we do is we have this proportional sign. It's 1 over 1/2 r squared. So when we square 1/2, we get 1 over 1/4 r squared. When we do a little algebra to that, we get the force being 4 over r squared. So it increases 4 times as much. A little problem here, if I have 2 metal spheres separated by a distance of 2 meters, sphere A has a charge of 0.05 coulombs, and sphere B has a charge of negative 0.001 coulombs. What's the force acting on each sphere? So the first thing we do is write down our terms. So we've got the constant K, 9 times 10 to the 9th newtons times meter squared over coulomb squared. Q1 is the positive 0.05. Q2 is the negative 0.001 coulombs, and the radius is 2 meters. So I write down my formula for Coulomb's law, plug in my numbers, solve, and come up with a final answer of 112,500 newtons. And it's an attractive force. So if we were to go on, here's your challenge. A physics student decides to use Coulomb's law to attract his prom date. He discreetly measures her charge to be Qg, G for girl, is a positive 2 times 10 to the negative 4th coulombs. He gives himself a charge of Qb equal to negative 3 times 10 to the negative 4th coulombs, how far should he stand from his potential prom date in order to attract her with a force of 10 newtons? So once again, if you can answer this question, give it to me before the bell rings, before the end of Unit 9, I will give you a piece of candy. Alright.